The first thing you notice when you work on this type of Philco is that everything is packed really tight. I mean, really tightly. This thing, this radio, this chassis, is an AM, FM, and shortwave, 2-band, I believe, shortwave radio. So this thing, there's a lot going on in this chassis. And because of that, you will find that everything, I mean everything, is packed tightly together, and every terminal has a lot of stuff on it. Add to that when Philco built this, they used some really short lead lengths because of the tightness, and some of the components they used maybe weren't exactly the most robust in the world. I'm seeing a lot of quarter-watt resistors in here. And for me, the quarter-watt resistors just have to go. I at least will put in a half-watt resistor. And I just want to encourage you on this if you just take your time. The thing you'll notice is that to get to any one component, you necessarily have to remove the solder from the leads that include other components. This output transformer is sort of in my way here, and I want to get it out of the way. There's some things going on around here that I would just be happier if this thing weren't there. When you work on one of these Philcos, the real thing you have to try to keep in mind is take your time. There's a lot going on inside this radio, and you really don't want to just start ripping into it because you'll lose your way really fast. And Philco schematics can sometimes be a little bit quirky. So here's the way I do things like this. I'll pick one terminal, like this one right here I'm in the middle of, okay? And I'll take my desoldering braid and I clean up all the solder off that terminal. Alright, and then I'll lift every single component up off of the terminal so that I can attach a new component of the same value to that terminal if I'm replacing the component. Otherwise I just take it off, I just lift it and I pull it aside. Okay, so I've got the solder off of here and I'm going to lift all of the components off. That one there, that one's actually good, but I'll measure it again since it's lifted off of there. And I happen to know that this one is not good. It's supposed to be a 47K and I measured about 88K. So I'm not terribly concerned about how I treat this component as I pull it off. But there we go, okay. Now I had already lifted off the 1 meg. So there were 3 components going to this terminal. This 1 meg right here. This little 47K, I'll put a half watt in there instead of these little dinky quarter watts. And then this 4700, this 4.7K. What I measured with this one is 4.8K. I can live with that. So I'm just going to go ahead and put that one back on first after I clean that terminal. Now I keep talking about measuring resistances here. And I do it all the time with them in circuit. Because when they're in circuit with other resistances, all that will happen if it does throw them off is that the resistance will measure lower, not higher. They'll never measure higher. If you measure a resistor and it measures higher than it's supposed to, then that resistor is bad. It has drifted high and it needs to be replaced. But it's true with any radio that's real crowded. You start to worry less about how pretty it is and more about making sure that everything is in the right place, and that you maintain wire dress the best you can. Now in these, just like Zeniths, it's real hard to be too concerned about wire dress because the wire dress is a mess. That's how they were made, and you know, I never saw any logic or rhyme or reason behind the way Philco did the wires. Now you just start putting components back on the terminals. Alright, so this 1K, brand new carbon comp. I learned something from watching X-Ray Tony. He goes by X-Ray Tony B. All right, he did an ICO ST70, and I didn't realize that when I started my ST70 that he had already done one. And I've been a subscriber for a while, but I missed that. I don't know how I missed it. But anyway, X-Ray Tony said something really interesting, that when you replace resistors in tube circuits, you need to be really aware that the resistors you're putting in are able to handle the voltages they're going to see. So I never really thought much about the voltage rating of a resistor. I just would buy resistors and put them in, and I never thought about it. But apparently some of the film resistors that are out there aren't really designed to withstand the sorts of voltages that are seen inside of tube gear. And it's funny, I seem to remember Bob Anderson talking about it regarding televisions way back when, but I still didn't put it together. So I'm kind of glad, though, that I've been buying all these surplus carbon composition resistors from Philco over the years, because the carbon comps are pretty good at high voltage. So that's kind of a good deal. That works out okay. Now I still, when I buy a batch of resistors over at Philco, I'll measure 2 or 3 of them before I start using all of them, just to make sure, because I guess they can degrade too. It has to do with moisture in them and that kind of thing. But anyway, X-Ray Tony made that point, and a lot of the resistors, more modern ones I had bought, I have actually no idea what their voltage rating is, and so I'm a little bit reticent about using them in tube circuits. I'll keep them around and use them in solid state stuff, but I really hadn't thought anything at all about using them in tube gear. So I'm going to have to pay attention to that. Let me go get a 47K to put in that spot right there, and I'll show you what I do after that. This, my friends, is everyday drama in my workshop. If I leave the door open, this is a constant thing. On a weekend day, this goes on all day long, or at least until one of them gets tired and goes to take a nap. But they never quit. It's always the same too. One of them comes up to push the buttons of the other one, they get into a wrestling match, and then Fred usually kicks Buster's butt and Buster goes away ticked off. That's just the way it is. And Wifey's always saying how it looks like it hurts. They're hurting each other. And I say, look, they're like brothers. Brothers always hurt each other. They beat the snot out of each other, and then they're best buddies later. That's kind of how it is with Buster and Fred. Oh well, back to work now. I like to wrap my resistors with shrink tubing. I've mentioned that before too. And I partly do that because it helps me to know if I ever have to get into this radio again, and I don't remember whether or not it was me that worked on the radio, well, this will be one of my ways of reminding myself. Plus, I don't actually color code, but using different colors sometimes enables me to find stuff really fast. So the colors may not mean much, but they do help me to determine where, like if one end of a component is one color, well then, unless there's some reason I wouldn't have done that, and there are a few, the other end will be the same color, and that usually makes it easier to find where it goes. Now you notice that I made the lead length longer than it absolutely needed to be, and then I kind of curled it a little bit. And the reason I do that is I like to not overheat the component, and a longer lead length helps prevent that when I'm soldering it. It really doesn't affect the wire dress. I've never had any issues with it. You could make the argument that it would affect wire dress and add noise and so forth, but I've never run into that. Yikes, I forgot to remove this one. That's what happens. It's like when you're driving and you're talking with somebody in the car. That's when you'll miss your turn. I don't like these dinky little quarter watts. I tend to get rid of them, but so there's a 10 meg. So I'm only seeing 6 meg. If I have any 10 megs in half watt, I'm going to go ahead and replace that. Well, as it turns out, the only 10 meg I have is this 1 watt, so that's what I'm going to have to use. Not the end of the world. It just seems like an expensive use. It seems like overkill, but it's all I got. And you notice what I'm doing. I'm removing one end of every component from that terminal. And then I can go ahead and put all the new components on that terminal, and then all the ends of the components that stick up, well, then they'll go to the places where the old component is also sticking up. Okay, so here I'll show you what I mean. So I left this 10 meg attached at one end, and I'm going to go ahead and install this 10 meg on the terminal I just cut it away from. All right, and then here's another one that goes to that terminal. And I tucked it down out of the way because I could. I try to start at the bottom of the terminal on the terminal strip and work up if I got several components so I don't make a mess. You don't have to wrap them a bunch of times. And if you got excess, when you're done wrapping it like once, twice maybe at the most, cut the excess off instead of continuing to wrap them. Okay, so like this guy right here. That little bit will fall out when I lay this down. Alright, so now I'm going to take this resistor and kind of tuck it down here out of the way. So what I had 3 components going to this terminal, as I mentioned. The 1 meg sits right here, so I attached it. Alright, and this one here I just disconnected this end. I'm not replacing that component, so I just disconnected it and left it hanging in the air until I got to wrapping all of them on there. Alright, and then this 47K, which is new. And then I did here the same deal. This 47K I knew went there, so I went ahead and attached it there. I'm going to leave this dangle now, and I'm going to solder these two so I don't get lost. And I'll actually solder this one over here too. The last thing in the world you want to do is have too many things not soldered. You'll get lost. And that's kind of my point. My point in bringing all this up was that it's real easy in a radio like this to get lost. And then you're looking at a schematic scratching your head because something in the schematic doesn't make complete sense to you. And that's why I make like literally a couple hours worth of video of the camera just panning around inside the radio from all different angles. You never see that because it's boring to watch as a YouTube video, but it's very useful if I ever lose my place in a radio. Something else I've learned too, if I don't need the soldering iron to be too hot, if I get it too hot, that solder will run like water down off these terminals and want to get down there to the chassis floor. And that's always a bad thing. When I'm soldering, I try real hard to touch both the terminal and the wire. That's how you get the best bond, of course. And then you go ahead and you clean off. If you missed some from before, you clean that off too. I use a lot of flux, as I've said before, but then I try to clean it up too. Yikes. I forgot what number that was now. Then you move on to the next one. And I forgot this guy right here. This is the wrong value, but it's supposed to attach right there. Here's something else too. If you get into a radio and you start seeing a lot of stuff that's not made by the brand that it should be made by, like this is Philco, you can see that. Alright. I don't know who made this guy. It almost looks like Philco based on the number, but see, that's Philco there. But this here is clearly not Philco. And I've seen some others, some Solar and other brands in here. When you see off brands like that don't belong in a radio, you know somebody's been in there. And don't assume that's the right value and just replace it. Always check it on the schematic. Alright, I'm going to shut the camera off and not bore you to death and move on and try and get the rest of these in here. This is a mess. Here's an example of what happens when folks get in and mess around with radios and why you can't just start replacing components as they are in the radio. You see that 0.22 microfarad capacitor, the big one, and see where it connects right there at that same terminal with those 330K and that 150K? Right? You see the 3 resistors coming together and that capacitor on the same terminal. There is that section in the schematic. Now you see the 330s, the two 330K resistors and the 150K. But look at where the 0.2 microfarad capacitor is. It is not connected to that same point with those three resistors. In fact, it is connected to the other side of this 150K resistor going to ground. The way I got this, and I confirmed it by looking back at the original videos of the bench test, this 0.2 microfarad capacitor was indeed connected to the point with these three resistors here, when it actually should be connected over here on the other side of this 150K. Now the other end of this capacitor, as originally delivered to me, was correct. It was connected to ground, and I have it here connected to ground. But see, I got bit because I was following the chassis as built. It was a Philco capacitor and looks like it should have been fine. But there was a lot of solder on that terminal, and somebody probably lifted it from here and mistakenly put it over here. Whether it was a mistake or on purpose, it's not correct. And so now I've got to lift this capacitor off of this terminal here and move it over to here. That's just one example. I found a couple of them in here. So just be really careful. Unless a radio looks absolutely pristine and untouched, don't do what I did and replace components as they show up in the chassis. Make sure before you do that that is actually correct per the schematic. When I install any component into a chassis, I like to use shrink tubing on the leads, and I've talked about this a little bit in the past, but I haven't really focused on it much. I do it for a couple reasons. I put the shrink tubing on, I mean, primarily the reason that, shrink tubing was even created, I think, is to insulate, basically do the same thing that insulation that comes on wire does. So I use it for that. Of course, when I put components in old radios, there's components going every which way, and you can always make a mistake when you're installing and touch two wires together. And I'll bet even that happened a lot when they were manufacturing these. But of course, those failed the quality testing and they never got out to the consumer. So what I do is I'll take a component like this resistor, take a piece of shrink tubing that I've just cut. You saw me cut it with my little Xuron snippers. And one thing I don't like to do when I'm soldering a component in is to put too much heat into the component. I just think it shortens the life. It can't be good for it. So what I'll do is I'll put the shrink tubing on like that. And I take my little tweezer nose pliers and I make a little bend, and then depending on how close the terminals are this thing's going to get mounted to, then I'll make a sharp bend like that, and then I'll start to make kind of a curve thing like this, right? And you've seen me do this, I think, but I never really talked about it. So I kind of do like a curve, like a loop back, all right? I do that on both sides of the component. And again, how tight I make this depends on how close together the terminals are that it's going to be mounted to. And if the terminals are far apart, well, then I don't need to do this. The reason I'm doing this is to increase the lead length between the component and the terminal it's mounted to. And of course, I do that because that reduces the heat that gets to the component. All right, so there we go. And so now I have this kind of deal like this. Now, that you have to be careful about how you bend this so you don't break it off of the component. Now, what that does too is it gives it some tolerance on how far apart, when I'm working with it, it gives me some tolerance, you see. It also tells me later, if I ever have to look at this radio again, that I've worked on this radio, because I don't know too many radio repairmen around here that do this. And finally, it also helps me to find components because I can kind of color code them a little bit. And I don't really have a particular system that I use. I just, if I, at a particular terminal, I'll maybe have every one of them going to that terminal be blue. And then the next terminal over be orange. That way I can kind of tell them apart when I look down in the chassis. And I'll show you in a minute. So now I put the shrink tubing on. Of course, I'd like it to look neat. You don't have to do this part here. You can leave this and just let the heat of soldering do it. But I like a neat look, and I think this does a better job. So I'll heat the shrink tubing. Now you might notice a couple things. I only heat it barely enough to get the shrink tubing shrunk down. The soldering will tighten it up if it's loose anywhere. That's number one. Number two, I aim the heat gun so that I avoid blowing hot air right on the component. Okay, so I have to get pretty close to the nozzle, but I do that so that I can heat it quickly, get just the area I want hot without getting a lot of heat into that component. Now this thing is ready to install, and let me show you some things in the chassis. All right, as we look down into the chassis of this Philco, I want to focus on this terminal right here. Let me point to it with something that might be easier to see. This terminal right here at the end of this piece of shrink tubing. Now you can see I've already kind of installed one component to it and did my little loop thing that I like to do. And I originally had removed all of the wires and so forth that went to this terminal, so I could clean the terminal up and kind of remove bits of wire that are left from disconnecting old components like these two guys right here. And now I leave these old components attached at the other end. Okay, so I just got this terminal I'm working with. I chose gray as the shrink tubing for these components. And I've already installed this 4.7 meg right here to replace this 4.7 meg. So I'll swing that guy out of the way and deal with it later. Now I've got this guy right here. It's a 6800 ohm resistor. Now I've prepared one of those, and I'll show you in a second. I'm going to install that 6800, but I should let you know that I also installed a 0.001 microfarad capacitor using the gray shrink tubing, but I kind of tucked it down here against the terminal strip, so it's hard to see. Now I should mention that this 0.001, that is what the schematic says it should be, and it makes sense. But the person that last worked on this radio installed this guy right here. Now, I think this is not a Philco capacitor. Let me get some stuff out of the way and show you. And that's what clued me off to this. Yeah, this is a Sprague. And so whenever I see a non-OEM capacitor, especially in something like a Philco, where they put their name on everything, then I start to get real suspicious of the value. So I turn this, and it may be tough to see, but this thing is a 0.01 microfarad. Looking at the schematic right here, it's supposed to be a 0.001. Okay, this is coming off the 7AF7 at pin 5. There's a 220K resistor, which I'll show you in a second. There's that 4.7 meg, okay, and they straddle this 0.001 microfarad capacitor, one side going to ground with the 4.7 meg. All right, well, as I showed you, they had a 0.01 installed in that spot. Okay, here's the 7AF7 tube. There's the 4.7 right there. Okay, it's coming off of this terminal number 5 right here. Okay, this 4.7 meg is going off to this terminal I've been talking about. Looking really carefully, you can see that this is the terminal I've been working on right here. Now, this is that's a 6800 ohm resistor that I pulled from that terminal. We'll look at that in a second. But here's that 4.7 meg right there. That replaces this guy that I have dangling over here. Okay, so the way I normally do these is like I said, I'll pull everything from one end at a terminal. And then I go ahead and mount the new components, and then I go to the other end of each of the old components and disconnect those and terminate the new component in those places. So there's that 220 meg I talked about. There's that 0.01 microfarad capacitor that is supposed to be a 0.001. And I've already installed the 0.001, one end of it on the terminal I'm working on. And you can see the yellow axial capacitor tucked down there alongside of the terminal strip. In this way, I work on one terminal at a time, and it helps prevent me from making mistakes. And by leaving the old components attached, like I've done with this guy here and like I did with this 6800 there, then it tells me where the new components will go. And it makes it really easy to do this without making a mistake. But remember that you can't always count on the component values that are on the chassis. You know, that 0.01 microfarad capacitor is a perfect example of that. That should have been a 0.001. And there it is down there again. you cannot count on what's on the chassis. The only thing you can really count on is what's on the schematic, and you have to always refer to that schematic as you're working. The reason I'm going into all this detail is just to kind of remind you that when you're working on a tight chassis like this Philco, it's a really complicated chassis. It doesn't look like it at first blush, but when you start to really look, there are a lot of small components in here with short leads. It's tight, number one, so it's real easy to make a mistake in there. So always refer to the schematic and take your time, work one terminal at a time. And number two, you never know who else has been in there. And this looks, for all the world, like this Philco capacitor, except I noticed it said Sprague on it. And so you have to be very aware of what's been put in there, because a lot of times people will put values other than what's supposed to be there because that's what they had. Will it work with those values? Yeah, sure. But you might have trouble aligning the radio. You might have some distortion. It might not sound quite right in the tone. Depending on where that component is, it can change the way the radio works. Yes, the radio will work, but it may not work the way you expect it to work. Take your time, work through these one terminal at a time, and sometimes you'll have, components dangling in midair until you get them all attached. But if you work one terminal at a time, you'll get through the radio faster and you'll have less troubleshooting to do at the end. And I've mentioned many times in my vids that I'm not the world's greatest troubleshooter. But that's okay because I take my time on these and I seldom have to really troubleshoot a major problem. And when I do, I learn something from it, and that's okay too. But I usually don't have to spend hours and hours and hours troubleshooting because I've taken a lot of time to do this the right way in the first place. All right, that's enough of my soapbox. I wanted to show you a little bit of where I am. I've gotten pretty much all of the components replaced, and you can see that by all the shrink tubing that's on these parts. And the new capacitors, of course. Okay, so I totally eliminated these two electrolytic cans, and I just built a terminal. There was plenty of room over here, and I just built a terminal strip here and used some high-quality Nichicon capacitors to replace those cans. There were supposed to be two 25 microfarad caps in there and a 20 microfarad. So what I used were three 22 microfarads. Now, this terminal strip's really easy to get to, and then if I have to put in a 4.7 in there to bring this closer to the 25 or a little over, I can do that. I haven't really touched this Philco Bakelite block yet, and I haven't really done anything with the fuse and the line voltage line coming in, so I'll do that pretty soon. The hardest part so far has been working around this band switch. I decided I did not want to pull this sub chassis out. There's too many things in there that are easy to mess up. These coils for the FM tuning, these slug tuners for trimming the FM, all this stuff can be too easily messed up, and I'd rather leave it be. I can easily get to this tuning condenser right here and the mechanism that drives it, so there's no reason for me to pull this out if I can help it, but that did make it hard to get to some of the components, especially down here at this end. What I did find, if you have one of these radios, it's probably got this little bracket right here too, and I'm not quite sure why this bracket is there, but it's easy enough to pull out with this one screw here. It lifts right off, and that made it, believe it or not, this little bracket was a real pain. Taking it out made it real easy to get to some components down here because there's a tube socket down there, the 6BA6, and there were some components I had to change on that. So that's pretty tough. There is a paper and wax capacitor that I cut the leads to, and I replaced it with a new capacitor, but I could not get that capacitor out of there without doing damage to the band switch, so I just left it in place. It's not connected to anything. It's not going to hurt anything. There are a lot of components that don't need to be changed. Now, these little plastic deals right here are really low-value capacitors. I'm not going to change those unless I have problems with the radio. There is a little choke coil down here that I left alone. There's one over here too. There are lots and lots of little tubular capacitors that I've left alone because I don't think they need to be changed. They usually are fine. So I'm almost done with replacing all the film capacitors, the paper and wax. I'm almost done with replacing all the bad resistors. There were a lot of bad resistors in this guy. And I'm almost done with replacing the wire and stuff and the electrolytics that needed to be done. I'm cleaning up now. I'll get the last of these paper and wax now. I'm going to shorten up this brown wire. It doesn't need to be this long. And I'm going to do some other things. I'll probably shorten up this orange wire. These look like replacements looking at the soldering where they're at. So I'll go ahead and shorten those up. I don't think that they need to be that long. In case you were wondering, I was just having a little workplace fun. Alleviate some boredom. So we've gone on for a while here. It's time to wrap it up. And we'll pick up the rest of this chassis in the next part of this series. And until then, I hope you have a great week. This is Michael from your Western Outpost in Salt Lake City. And that's all for now.